What is up, FVACSP? I believe this is the third part, should be the third part of 4.4 search algorithms. Specifically, this is about a how, but really, it's focused on breaking down the um, binary search algorithm. And so let's take a look. I really want to make sure that you all go through these notes because it is really, really important. I'm not going to sit here on video and tell you, read this all to you, but I will say that, this text is very rich in the knowledge that you need to pick up. But I wanted to point out this right here. This kind of search where you basically take a large, like a phone book, and you open it to the middle, and then you determine if your item you're looking for or your name you're looking for is in the front half or the back half. And if it's in the front half, you throw away the back half, and then you take the front half and you split it again. Okay, is it in the front half of the front half or is it in the back half of the front half? Split it again and keep only the half you need. Binary, so splitting in half until you end up with your result that you are looking for. So you're basically going to be taking your volume or taking your array, taking your list, and cutting it in half every time you iterate, every time you go through your algorithm until you end up with the item you are looking for. So let's really break this down. So this kind of search where you split what you are looking for in half each time is called binary search. The word binary describes anything composed of two parts. In this case, you are splitting the dictionary into two parts with each step of your algorithm. Very, very important. Also, to point out, here is an example code. I'm not sure it actually works right. MakeCode tries to give you this. I'm not sure this link works correctly. So you're going to probably want to do what I did, and I went ahead and created my own list. Here they're talking about 200 words. No way, Jose. Um, I went with 26, which is still a pretty big list. So I have 26 words in my list, more than enough. You could just use 10. You don't have to do it. The more in the list, the more names, the more words in the list, the better it is. I have a theme to the words in my list, and I will show you those to you in just a second. So here it's basically telling you, like, hey, use this example code, blah 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 blah. No. What I did is I used, let's maybe if I can zoom in. So I went A B C D all the way through Z, and I put a fruit name in all lowercase for each letter. So jackfruit, kiwi, quince, ugni, vanilla, which is actually a fruit, watermelon, sikwa, I think it's sikwa. That's watermelon in Chinese, basically. Yangmei, zucchini. So there's all the fruit names in my list. So you are welcome to use this. I will actually put, I guess maybe in the description or something, I can put a link to this program so you can use my words as well. As well as I went ahead and jumped a little ways down in the program, mostly to get ahead because I think you guys can do this. One thing I realized didn't copy is setting my beginning. So set beginning to 0, set ending to length of array, which is the length of the word list, -1. That's a standard operating procedure. Set the middle to the beginning plus ending, integer division by 2, and then set word to find. Ask the user try and guess a fruit on my alphabet list. So giving them a hint that there's a bunch of different letters from the alphabet starting the names of fruit. I guess maybe that describes it pretty well. And then here I have a while loop. I'm going to do a comparison inside of my while loop, I have an elif statement. So if this condition, then do this stuff in here. Else, if this condition is true, then do this stuff in here. Everything else, do this. So let's jump over to the directions, and I'm going to figure out where I am. Define two variables, beginning and ending. Yep, did that. Beginning should be 0. Ending should be length of array word list -1. Yep. Set up middle. You also need to know what word to find. So create another variable called word to find and ask the user to enter a word. Boom, did that. Add a while loop to your code. Boom, did that. You'll define the condition a little later. For now, leave it as while false. I went ahead and added a less than or equal to. Now you can follow the algorithm outlined above, checking if the middle word is the one you want to find. Add an if true, then block to your code. Set the condition to check if word to find is equal to the value of the word list. This is really important that you set this up correctly, okay? So the first if, we are going to check if word to find, okay, so go to your variables. If word to find is equal to word list. Well, remember, you have to go to arrays here. We got to change this to word list. And then we want to get the value at, well, where do we want to get the value at? We want to get the value at the middle index, okay? So we just calculated the middle right here, so we can access it by dropping it in there. Now, let's say you get lucky and it just so happens that the fruit you picked was the middle fruit on the alphabet. That would be fantastic and it would make things so much easier. All we'd have to do is go to game and splash. Well done. You guessed the fruit. I think I misspelled that. Well done. You guessed the. Well done. You guessed the fruit. And if you remember, we need to add this break in order to break the loop and break out of the while loop, so we can move on in the program. If this is true, splash the success message and break the loop. Boom, bingo, did that. What if you don't find the word? Well, per the algorithm above, you need to figure out whether to continue searching the front half, the half that that comes before the word, or you need to figure out to search the half that comes after. Okay, binary search. Split it in half, check the middle. Is it going to come before or is it going to come after? If it comes after, get rid of everything in the before, check the middle of the after. Boom, split it in half again. Is it going to be before that or after that? And you're now cutting your search algorithm is cutting the population of your things to be searched in half, cutting it in half every time you go through your algorithm. Very, very important. It's a much more efficient algorithm in some regards in order to find something. So what do we do? Well, we need to add an else if clause to your if statement. Boom, already did that. It's right here. Set the condition to check if word to find comes before the value of the word list. Well, if you remember from the directions above, if it equals it, this compare, we have right here, we have compare. If it equals it, compare is going to give you 0. If it is before it, compare is going to give you, it's going to return a -1. If it comes after it, it is going to return a 1. So right now we're trying to check if the word comes before. So we're looking for a condition of -1. That's why I already have a -1 right here. So we want to compare word to find to this right here. So we want to compare that word list to the middle. Sorry, we want to compare the word to find to the middle word from the word list. And that's going to tell us that comparison is going to, if it comes before it, it's going to give us a -1. And so that condition will then allow us to control which direction we send our algorithm. Now, let me tell you the logic here. There's a bunch of logic right here. What I want to jump to is in your else if clause, set the value to the ending, set the value of ending to middle -1. Okay, what the heck? What does that mean? Well, if we check and our word that we're looking for comes before the middle, then what we can do is we can take our ending and we can move the ending from the very end, which is zucchini, and instead, like, what's the middle here? So 26. So it's going to be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So mango is going to be the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. No, just kidding. Oh, it's going to be 13 and 13. Silly. So I think the way that the algorithm will do it is it's actually going to be nectarine. So nectarine would be the middle. And then what will happen is it will jump back. So then we're going to say, instead of zucchini being the ending, we're going to say we now want nectarine -1 to be the new ending. So again, let me reiterate that. If we do run our algorithm and we find out that our word is not the middle word, but it's actually a word in the first half, then all we have to do to run our next loop is move our ending from the end to the middle -1. Okay, so now our ending is going to be here, our beginning is still here, and then we're going to run the algorithm again, but just on this front half. Okay, you can do it likewise. If you run to the middle and it's not the middle word, and then you check and it's not the first half, it's the second half, then you're not going to move the ending, but you're going to move the beginning. You're going to move the beginning from apple to nectarine +1. Okay, so this is going to go, the beginning is then going to go from apple to the middle +1, and now all you have to do is check from the beginning to the original end. And that's what we're going to do right here. So let me put it here. So let's go to variables. Let's go to set. The first one is we're going to actually move the ending. So we're going to move the ending to, I believe it is middle -1. So middle, and then let's get some math here. Middle -1. So now basically what we're doing is we're saying, like, first take our whole set, go to the middle. Okay, is it the middle word? Yes or no? No? Okay, next thing, check if it's in the first half. Is it in the first half? Yes or no? Yes. Move the ending from the end to the end of the first half and then run the algorithm again. No. So no, it's not in the first half. That means it is in the second half, because it has to be. It was in the middle. It's not in the first half. Has to be in the second half. Move the beginning to the beginning of the second half. Hopefully that makes sense. It's a lot of words, I know. So here we want to set the beginning to the middle +1. Okay, middle +1. And then this is going to be the middle minus 1. So moving the ending or moving the beginning. Boom. That will handle the setup for our next loop of our algorithm. But what we have to do is we have to reassign middle. So we have to set middle to this new beginning value right here plus the new ending value that we got from right there, integer division by 2. Then what's going to happen is this middle value is going to be the new middle, and it's going to go back through this while loop, which we haven't defined these parameters, but it's going to go back through here, and so wherever middle is used, it's going to have a new middle value. Okay. Set middle to beginning plus ending. Yeah, okay. Now, the last thing we need to do is this final condition. So add the condition to your while loop that checks if beginning is less than or equal to the ending. Now, the explanation is all of this. Okay, I want you to look at it. I want you to look at this and read through this, and because I think after watching this video, which is quite long, and I apologize, but after watching this video, after doing this yourself, I think it will all make more sense. But I really, really want you to read that paragraph. Good heavens, I keep doing that. I really want you to read that paragraph from this instruction down all the way to this instruction, because that's really the end of the code. And then this is an illustration of if you have 200 items, your first binary loop is going to cut it into 100 items to search, and then 50, and then 25. So essentially, you could find the longest search for a binary search of 200 is going to be 7 iterations or 7 steps. Whereas if you searched it sequentially, each item represents its own step, which means 200 items, it's going to be 200 steps. This one's only 7 steps. So in this case, a binary search is more efficient. Let's finish the program. So while beginning is less than or equal to ending. So basically saying that our beginning value is going to, as long as our beginning value is less than or equal to ending, this while loop needs to go, needs to function, needs to keep going. Okay, so let's just check to see, make sure it works. We'll do Agni, make sure it returns. So for some reason it did not return my value, which is interesting. I'm sure I probably did something wrong. Looking at my example code, set ending to middle -1, set beginning to middle +1, set middle to B. Well, that is the code that we are going to go with. This video is already extremely long. If you can find my mistake, please feel free to point it out. I will find it as well, and I will post a little tiny recap video. Promise it'll be 90 seconds or less of what the final code looks like and how it works. Because I have a program right over here that does work. So until the next one. Actually, that is it for these ones. 4.4 concluded. Part 3 done. Sort of. As always, stay positive out there, coders.